screenshot function in my Chromebook and an extension that allows me to record the screen.
Let me do my original greeting, dude. What's going on, physics students? Welcome to the class that made up for the class that was just kind of a crappy class yesterday. Because we didn't have audio. I'm sorry. I apologize. I hope that this button will work now, right now. Anyway, we're moving on to actual physics, and I hate to say it, but up to this point, you actually haven't learned straight up physics. We've just been learning how to do math. But as you can see, the math is actually not that easy. So it's good that I review that for you. Because to be honest with you, between you and me, every single time a person says, I hate physics, I don't understand physics, it's because they have trouble with the math. And so I feel like if I spend enough time getting you guys used to the math, then maybe you guys will actually enjoy the physics. So anyway, let's get started on physics, and we'll start talking about actual physics stuff. We're going to be talking about position, distance, displacement. We're going to talk about the difference between speed and velocity. We're going to talk about the word acceleration. And then I'm going to introduce to you the 4 most important equations that you are going to learn to love and hate, probably at the same time, for the next, like, 10 weeks. Okay? So maybe I might be able to get through all of this in the 10 minutes that I have to lecture, or 15 minutes that I have to lecture. We'll see what we can do. So, we're going to talk about the position, distance, and displacement. Before I start talking about motion, what I need to talk to you guys is the difference between this thing called a scalar and a vector. Have you heard of that difference before?
Yep. Does anyone else know what a scalar and a vector is? Mr. Dull, do you want me to tell everybody what that is?
Well, it depends on if Catherine knows what it is or not.
No,
Catherine,
what is?
you know what this is?
A scalar and a vector.
A scalar.
All right.
I couldn't hear because you guys were talking at the same time.
No problem. Justin, why don't you explain to us what a scalar and a vector is?
A vector is just a distance. A scalar is a vector and a quantity that describes which direction the vector is pointing.
Okay, listen to
And
exactly
how fast.
what Justin said and then switch it. You got it exactly the opposite. A scalar is just a distance. But a vector
Is a distance and a direction.
is a distance and a direction. And so that's the difference between distance and displacement. For example, let's see. Here's Honolulu. And then let's say Hawaii Kai is over here.
It's actually a little bit higher up than that. But
I know,
let's
but I
just
didn't
assume
have
you're
enough
looking at
room, all right?
where it
So calm down. All right, here's Honolulu, here's Hawaii Kai. Let's pretend, and I don't know the exact distances here, but let's pretend that the distance from here to here is 20 miles. You got it?
Yeah.
So
Okay.
so Catherine,
Yeah,
you're in Honolulu, and I'm coming to meet you, all right? And I call you up, Catherine, and I say, "Hey, Catherine, I'm sorry, I'm going to meet you, but I'm running a little late." And you say, "Well, where are you?" And I say, "Well, I'm 20 miles away from you." I gave you a distance. From that information,
Now, if you wanted to give her a vector, you would say, I'm 20 miles away and I'm east or southeast from your position.
dude, let me finish my thing. Don't just interrupt me. I said I'm 20 miles away from you. My question is, from that information, Catherine, can you conclude that I'm exactly in Hawaii Kai?
Wait, no?
Why not?
Because 20 miles away from Hawaii Kai, right?
No. I said I'm 20 miles away from you. You're standing here. You're in Honolulu.
Oh.
I call you up and I say, "Hey, I'm running a little late." And you say, "Well, where are you?" And I say, "I'm 20 miles away from you right now."
Well, I mean, you could be in the Pacific Ocean if you're 20 miles away from me.
I could be in the Pacific Ocean. I could be in Hawaii Kai too. I mean, if we really think about it, I could be in an airplane jumping out of the airplane, and I'm technically 20 miles away from you. You know?
Mhm.
So, in order to give you better information, I have to provide for you more information than just the distance. Okay? So, what I need to provide for you at that point is I need to provide the direction as well. As Justin alluded to, or he said, if I wanted to specify that I was exactly in Hawaii Kai, what I would probably have to say is I'm 20 miles east away from you. Yeah, that's correct. East. Right?
Yep.
Because that indicates that I'm 20 miles in this direction away from you. So that's what the difference between a vector and a scalar is. A scalar is only the magnitude. It's only the distance or the amount of information that will tell you how far away something is. But the vector has both a magnitude and a direction. It's kind of like how in Despicable Me when they said, I'm Vector, because I have both magnitude and direction. He goes, oh yeah. Anyway, I don't know if you've seen that Despicable Me. There's this dude named Vector in it, and I was like, hey, that's a physics joke. But do you understand? That's distance, and there's a difference between distance and displacement. Displacement is just like distance, although it has more information because you also have a direction in this. Okay?
Yep.
So when we deal in physics, we actually like dealing with the one that has more information. So we're going to talk about displacements. We're not going to talk about distances as much. Cool? All right, let's move on. All right. The distance is the total length you travel, whereas the displacement is a measurement of how far you've gone, wherever you start minus wherever you end. Does that make sense? Here, I'll give you. I'll make the analogy for you. Say that we got Hawaii Kai, we got Honolulu, and over here is Moanalua. You guys got it? We got Honolulu, Maunalua, Hawaii Kai. And let's pretend that Maunalua is 10 miles away. All right? Now, Catherine, you live in Honolulu. You're going to drive to Hawaii Kai to go pick me up. So you go and drive to Hawaii Kai, okay? Then we got to go and have some coffee over in Maunalua and meet up with Justin. So we drive all the way down to Maunalua. You got it?
Okay.
Now, here's my question. What is the distance that you traveled? How many miles is going to be clocked on your your odometer?
The distance between Honolulu and Hawaii Kai plus Hawaii Kai and Honolulu.
Okay, so that's what, 20 miles plus another 30 miles, so that's 50 miles?
Yeah.
All right, exactly. It's your distance is you would tally up all of these things. Now, I told you that this displacement is only the difference between where you ended and where you started. So, Justin, what is your displacement? Catherine, you can jump in on this if you want, but
10 miles.
Your displacement is 10 miles.
Your displacement.
Yeah.
Your displacement in miles is your total distance straight as the crow flies from wherever it was you started out, regardless of whatever directions you went to get there.
Okay. I agree with both
That's
of you.
your
Catherine's answer was the shorter one, 10 miles. But you're absolutely right.
It's your distance from the starting point.
It's your distance from the starting point, regardless of how you got there. But then again, of course, if I ask you for the displacement, you not only have to tell me 10 miles, but you have to tell me 10 miles west.
10 miles in.
10 miles backwards. 10 miles in the negative direction. 10 miles west.
10 miles. Okay, 10 miles.
Does that make sense? You have to both give me a magnitude and a direction.
I have this down.
I know you have this down, but it gets actually complicated if you're not careful. All right. What's the difference between speed and velocity? Now, do you understand the difference between distance and displacement? Yes? No?
Yeah.
Okay. The same difference is between speed and velocity. And it really kind of upsets me when I listen to like NASCAR and they're saying, "Oh man, that guy's moving at a high velocity." And I say, "No, technically he's moving at a high speed. Because unless
Because
you
he's
want
not
to
going anywhere.
Well, no, I mean he's moving at a high velocity. Yeah, he's going, but unless you need to like specify a direction that he's moving, he should say he's moving forward at a high velocity. Yes, technically that's correct, because you've given me a direction. You've given me forward. He's moving forward. That's a direction. And a high velocity means he's moving at a high speed. But technically, if you're just on the radio and you're announcing it, and you say this guy's moving at a high velocity, technically you should say high speed, because speed is only the number. The speed at which he's moving, but the velocity would be both the magnitude, which is the speed, and the direction, which is you give coordinates. You give a direction doesn't need to be north, south, east, west. It could be plus or minus. He's moving in the positive direction or the negative direction. It could be left or right. Does that make sense?
Yeah.
So the
Yeah.
speed is distance
Okay.
over time, whereas the velocity is equal to the displacement over time. We cool with that?
Yeah.
All right. So the average velocity is displacement over time. So here's the thing. Check this out. Let's do this. Justin, after we go to, we meet up with you at coffee. Okay, we leave you back in Maunalua. I'm going to catch the bus home, so all Catherine has to do is go back to Honolulu. So she goes back to Honolulu. What was your average velocity over the course of the day? Catherine, you started off in Honolulu. You went to Hawaii Kai, you went to Maunalua, and then you went back home. What was your
So
average?
Dudley, you're talking cumulatively as a result of all travels throughout the day, right?
I'm talking
Cumulatively
about.
from every
I'm
single-
talking about from the beginning of your day. So when you come back home and you go back to bed, at the end of your day, what was your average velocity that you moved over the course of that
Do you
entire
want
day?
do you want me to take the speed of rotation of the Earth into account?
No,
Okay.
because I don't think that I can teach you the math that involves the speed of the Earth.
Speed of the Earth is 24,000 miles an hour, then.
All right, but wait,
That's not the-
I'm talking about relative to where you started and ended. Well, here's my
Okay.
question for you: is what is your displacement?
the relative displacement,
Well,
unless
no,
we
no, no,
travel
don't tell me the
an
philosophical
equal
answer.
amount,
Justin,
I
stop.
traveled an equal
Justin,
amount
stop.
of distance
I'm gonna
around
mute you.
the island as I would be if I went straight.
All right. My question is, you need to give me a number. It's just a simple question. What is your displacement?
Displacement when you
Justin.
get back to Honolulu.
Yeah. And Justin, you can answer. You can just chat in your answer. I muted you only because I told you need to stop, because I'm not asking for the philosophical answer. I'm just looking for what is your displacement. If you started off, you left your bed, you went down to Hawaii Kai, you went back to Maunalua, and you went back to Honolulu.
0. Right?
It's 0. So I asked for you, what is your average velocity? If your 0 is your displacement in the numerator, then technically your average velocity for that day, it doesn't matter how big the time you divide by. What's your average velocity?
0.
0 still.
Huh.
Justin, does that make sense to you?
Yeah.
Okay, cool. Now I apologize,
Well,
Justin. I hope you don't take
nothing
offense to me muting you for that short period of time. You're just getting really excited now. I needed to make sure that everyone understood. All right. So let's see. The graphical interpretation of the speed is all right. One way that we can look at the speed is this. Now, this is actually what makes me really excited about this kind of stuff. If you're moving, all right, Justin, say you're driving this time, and you're moving at 10 miles per hour, okay? Or let's say you're walking, moving at 10 miles per hour. So here's 1 hour, here's 10 miles. You start off over here. After 1 hour, you get to 10 miles. Got it?
Okay.
After 2 hours, you get to 20 miles. So up here.
Okay, Mr. Dalday, I can see where you're going with.
All right. So over
That's
here's
the-
time,
that's what you would call
measured in
linear-
hours, and over here
you call
is
linear speed.
distance, measured in miles. Are we cool with that?
Yeah.
Yep.
Now, Catherine is walking as well. She's out for a walk, and she walks, and this is what her graph looks like. Okay, this is Justin. This is Catherine.
Okay.
What
How's
can you
her
tell me as
speed?
the difference between Justin and Catherine?
I'm walking slower.
How did you conclude that?
Because slope
And
similar increase over larger distance.
Okay.
Very simple.
All right, Catherine, I'm sorry, you were saying something?
I'm just saying because by the time reaches 2, I'm at a smaller distance.
All right. I would say that the easiest thing to look at is you look at the slope, right? Because the slope of it tells you your speed. Whatever the slope is, this one has a bigger slope, so that actually will give you the numerical value of your speed. Because your slope on this graph is the rise over the run, and rise over run is distance divided by your time. Hey, that's your speed that you're moving at. Agreed?
Yeah.
Now, and the slope here is different from that. Now, if you were actually moving with some kind of acceleration, the graph would look like this. Say that you got faster and faster and faster and faster. You started off kind of slow and you got faster and faster and faster and faster and faster. Here's my question.
Okay.
Is what is the slope of this curvy line? Do you guys see the problem that we're going to have here?
You wouldn't describe it with a curved line.
No.
Sorry, you wouldn't describe
This
you
would be
wouldn't
the
describe it with
graph.
y equals mx plus b. You'd be describing it with what's known as a linear function, one that deals with quantities in the form ax squared plus bx plus c.
All right, I hate to say it, Justin, but you're kind of talking crazy. I don't understand what you're talking about. What is the slope of this curve? No, you didn't stump the teacher. You just didn't explain yourself. What is the slope of this curvy line?
Oh, I can't give you that right now, but I can tell you how to solve it.
Well, Catherine, you're in calculus, aren't you?
Yeah, you could find a slope at the point using limits.
There we go.
But there's
There we go. This is what we do. And you know you do not need calculus in this class.
Solving it within that area.
That's exactly
Similar to
right.
what we're doing now.
You, Justin, what you're
I
saying.
can't hear when you guys are talking at the same time.
Yeah, I know. I'm gonna have to. You know what I'm gonna do is I'm gonna change the style of conversation to make it so that I'll talk and then you guys can chat it back to me. Cool? All right. So can you hear me? Say yes in the chat bar. Cool. Awesome. All right. So here's what I'm thinking is I think that what you guys were saying is that I can't find a slope for this thing. The concept of slope really only applies to lines. So what I'm going to do is I'm going to find a localized slope. Basically meaning I'm going to find the slope of this point right there. Or the slope of these 2 points. And then just draw a line that connects them and then I can find the slope. That's pretty simple to do. Now, if I want to find the slope of these 2 points, or of this 1 point right here, I would find this slope right here, which is the line. We call that a tangent line. It's the line that touches this curve right here. Does that make sense to you? Now, Catherine, I don't know if you've learned this in calculus yet. Are you in Mr. Loving's calculus class? Or are you in calculus?
Wait, sorry, I just unmuted myself for a second because like I can't see anything on my screen, so I'm gonna log out of the class and go back in.
All right, cool.
But yeah, we're
Mr.
learning
Dolly, I can't be in here anymore. I actually have to go to Mr. Loving's class right now. It just started a minute ago.
All right, go for it. Sorry, I went overtime. Catherine, are you going to be good to hang out a little bit?
Wait a
Yeah,
second.
I'll be right
Never
back.
mind, I can still be in here.
No.
Candace had it up and I can still be in here.
No, Justin, go down to Mr. Loving's class because technically this isn't my time slot. It's his time slot. He should take precedence. It's his class is at 9:45.
Yeah, but it's not showing up though for some reason.
Oh, his Canvas is starting to have a hiccup.
Yeah, Candace had it.
All right. Well, when his pops up, you need to jump out and get into that class because that's his precedent. He gets precedence over me on today.
All right, then that's okay.
Since I stole his time. Actually, I didn't steal his time slot. I stole English 3 and 4's time slot. Catherine, can you see?
You're not stealing anyone's time slot,
All right.
Mr.
All right, so check this out. What we can talk about, and Catherine, have you learned this in calculus yet?
Yeah, I have.
Okay. All right. Now, the way that we do this, and this is a calculus thing, and I'm going to start teaching it to you now. But I'm not going to make you learn calculus in order to get through this class. But I just kind of want you to get the ideas of it because I'll be honest with you. Here's kind of what happened. Isaac Newton, one of the fathers of physics, invented physics, and he started talking about all this stuff. And then he brought it up, and he wrote the book on it. And then they said, "Well, none of this makes sense. All of your science here is baloney because it doesn't agree with any of the math that we know of." And Isaac Newton basically said, "Yeah, it's because you guys don't know math."
Yes.
And so he went back and he wrote Principia Mathematica, and he basically invented calculus to help explain physics. So that's why in physics you're going to see a lot of calculus. And then what's cool is the calculus applies to all different kinds of things. So here's how we do it: is basically we don't even know how to find the slope of this line right here. I mean, once we have this line, we can find the slope. But the thing is, if I give you 1 point and I ask you to draw a line through that point, it's impossible. Well, it's possible, but you can't draw the exact line that I'm thinking of. Because technically, a line that goes through that point. Because technically, a line that goes through that point could be this one, or it could be this one, or it could be this one. Does that make sense?
Well, you find what the slope approaches to find the line.
Exactly, but to do that, we would need 2 points, right? So we take 1 point on the graph, and we take another point over here, and now we can find the slope because you can easily find the slope of 2 different points. You connect those things, and you find the rise over the run, and there's your slope. See what I mean? Then what we do is we move this second point closer and closer and closer and closer to this first point, and as they get really, 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 really close, they're going to turn into this line over here, and that's how we find the instantaneous velocity. It's the velocity that you're moving at that instant in time. So actually, the speedometer on your car, it's showing you the instantaneous velocity. It's showing you the speed that you're currently moving at that time. It doesn't show you the average velocity you've moved over the course of the day or whatever. Does that make sense?
Yep.
All right, cool. That's the idea of how calculus fits into this.
But your car doesn't show you velocity, it shows you speed, right?
Yeah, you're right. It doesn't show you velocity; it shows you speed. Unless, of course, you have one of those cars that has a built-in GPS and it has a little like, you're going north and northwest. Then technically, it is velocity, right? But
Oh,
you're right. If it's
Okay.
just showing you the number, then you're absolutely right. It's only showing you speed. So this is, like I said, this is how we find the average velocity. Is we make the distance between these two times, because there's a time over here and there's a time over here, and we make that distance between those two times closer and closer to zero. We make it smaller and smaller and smaller. That's why it says delta t equals zero, or delta t leads towards zero. So we're going to talk about acceleration, and you know what? We're out of time. I told you I would go from 9 to 9:45, and because I spent so much time in the first, explaining problem 52 to you guys, we ran out of time on this side, but that's fine. I'm going to stop the archive and have a nice day, but don't go just yet. I want to ask you a question.